For lesson 69, we're working with simplifying complex expressions. We worked with these guys the other day. For instance, when we tried to take the square root of -9, and if we tried to plug that into our calculator, we found that it was a domain error. Okay, simply put, we can't divide by, or we can't take the square root of a negative value. Okay, that was until we introduced the imaginary I. So it's with these complex numbers, understand, not only can we do algebra work with them, but we can also graph these guys. Up to this point, when we've looked at the coordinate plane, the horizontal axis has always been the x-axis, or the x value of the ordered pair. And the vertical axis always represented the y value. Okay? The game is going to change just a little bit. With a complex number, recall, the first value always represents the real part, while the second part, the b value, always represents the imaginary part. The first part is going to be our x value from now on. Okay? And the b part now is going to be our vertical axis, the imaginary part. So let's go ahead and take a look at example 1, part A. We have the complex number 3 plus 4i. 3 is our real, 4 is our imaginary. The first part is 3, so that's going to be our real, that's our x-axis. We're going to march 3 units to the right, and then we're going to march 4 units up because it's positive. And this is an example of graphing in the complex plane. That point A right there. Let's take a look at B. -2 minus 3i. Well, because 2 is negative, okay, again, now instead of marching 2 units to the right, we're going to go 2 units to the left. And now it's -3, so instead of going up 3 units, we're now going to go down 3 units. And there's going to be our point B. So after points A and B, understand, don't overthink this. This is a new concept for us, but at the end of the day, the real part is your x, the imaginary part is your y. It's just like an ordered pair. If you'd like to look at part A, 3 plus 4i as the ordered pair 3, 4, that's perfectly fine. Same thing with B, -2, -3. Okay, we just plotted those just like we're used to our coordinate plane, but now the real axis, or the real part, is the x-axis and the imaginary is the y. Let's take a look at part C. Okay, now we have -4i. Now understand, there is no real part, so we're not going to go left or right either direction. But instead, all we're going to go down is 4 units, plot our point, and that's going to be point C, -4i. Lastly, if we look at 1, 1 is real because there's no I attached to it, so we're going to go 1 unit to the right, and then we're not going to go up or down. So there's our point D. So once again, if we wanted to look at these two with our ordered pairs, understand the -4 is my y, that's my imaginary part. We did not have a real part, so it was 0, -4. And then if we look at 1, 1 was our x value, our real part. We did not have an imaginary part, so 0 is going to be my y. So that's how we graph complex numbers in the complex plane. Okay, the real axis, or the real part, is your x-axis. The imaginary part is your y-axis. These are good examples to keep in your notes. The next thing we can do with complex numbers is find the absolute value of them. When we find the absolute value of a complex number, really all we're finding is the length from the origin to that point on the complex plane. To get a good visual of this, I want you to look at page 489 in your book. Notice they give us the complex number a plus bi. So if we graph a plus bi, which we just talked about, a is going to the right or left, b is going up or down. We plot the point, and notice the absolute value is the distance from the origin to that point on the graph. So essentially, if you're looking at that, really what we're finding is the hypotenuse of a right triangle. So the absolute value is really nothing different other than the Pythagorean theorem, and you can see that right here from the definition of it. It's the square root of a squared plus b squared. Couldn't get much simpler, right? So, for example number 2, we're going to find the absolute value of these two parts, or these two complex numbers. Part A tells us 3 plus 4i. Well, simply enough, square root, I identify what my a is, and I identify what my b is. My A is 3. My B is 4. And I square both of them. If we simplify, 9 plus 16 square root of 25, absolute value 5. It is that simple, guys. It's a new concept, but don't overthink it. When they ask for the absolute value, all you are doing is using Pythagorean theorem and solving. Now understand, when we do the absolute value, you do not have to use the I. The I goes away. Just use that 3 and just use that 4. Let's try one more. Let's take a look at B. Once again, my A part is -2. My B is -3. So square root. -2 squared plus -3 squared. I simplify. 4 plus 9 square root 13 does not break down, so I'm going to leave it as a square root of 13. Once again, I can't overemphasize this enough. Don't overthink this. The absolute value is just simply the Pythagorean theorem. You do not have to use the I. It is just the A and it's just the B. Okay? If you want to look at another example, I have one more in example 2 on page 490. You can look at that on your own. But once again, these are really good examples to keep in your notes. Okay, the next thing we're going to do with complex numbers is we're going to multiply these guys. Okay, this is relatively the exact same thing we do with numbers and variables already. Okay, nothing's really going to change. We got this -4i out in front, and then we need to distribute that to the 7 as well as the 3i. Well, if we take -4i times 7, 4 times 7 is -28. And then I have that I there, so -28i. Simple enough, right? Now we need to distribute to the 3i. -4 times 3 is going to get us -12. And notice now I have two i's, so it's going to be I squared. Now recall from the other day, we talked about the properties of I, that I is equal to the square root of -1. We also talked about the fact that I squared, and this was talked about just briefly, I squared is actually equal to -1. And this is the property that we're going to use right here on this problem. The -28i we can't simplify, but the 12i squared, I'm going to replace with that I squared with -1. Here I'm using this property. And now we distribute the negatives, or multiply. And the last thing I want to do is always get my form into A plus BI. So understand, 12 is my real part here. The -28 is my imaginary. So I'm going to bring the 12 out in front, the 28 behind, and now I have it into my A plus or minus BI form. And I got 12 minus 28i. Last one that we're going to do is part B. Notice we got two binomials, two complex numbers. Once again, it is the FOIL process. So let's begin. 5 times 6 is going to get us 30. And then 5 times -2i is -10i. 4 and 6 will get me 24i. And then lastly, +4i, -2i. My answer is going to be -8i squared. Okay, so at this point, I have a couple of i's and I got an I squared. So let's condense some of these. These two, we're going to treat those like terms. So I got -10 and I got +24, so I got 30. That's going to reduce down to 14i. Treat them just like they're like terms, like radicals, like variables, you name it. -8. And once again, what's I squared? I squared is -1. So here it is. Okay, so now I got 30 plus 14i. -8, -1. I get +8. Then lastly, 30 plus 8. I get 38 plus 14i. Nothing to it, right? Complex numbers. They like to scare you. They like to give you the illusion that it's something totally different, but at the end of the day, we use our exact same process. We can either distribute or we can FOIL these guys. Okay, and as long as you keep in mind these properties up here, I is equal to the square root of -1. Also, I squared is equal to -1. You'll be using those throughout this entire lesson. I have one more example that I'd like to go over with you. We're actually going to skip example number 4. We will save that when I get back and I can talk or go over that with you in person. Last one I want to look at is example number 5. We're going to divide 3 by 6 plus I square root of 5. So 3 is going to go on top. 6 plus I square root of 5 will go down below. Okay? Now understand, we don't like the square root down below, am I right? That's what we've been taught from day 1. So, if you can imagine, we're going to multiply by what we used to call the conjugate. Nothing's really going to change. The first term is going to stay the same. And now what we're going to do is flip the sign of the second term. So my conjugate for this particular problem is 6 minus I squared root of 5. I'm going to do that to both the top and bottom. I can do this because that value over the same value is still equal to 1. And now I'm just going to distribute. And then if you understand the conjugates, again, you don't have to do the O and the I of the FOIL process. All you have to do is the F and the L. So let's go ahead and simplify this. Okay? I'm actually going to leave it as, or let's go ahead and distribute. We're going to distribute the 3 on top of the 6 to get 18. And then when I take 3 times the negative I square root of 5, I'm going to get minus 3I square root of 5. That's all I can do with that. Divided by 6 times 6 will get me 36. Now once again, I don't have to do the O and the I of the FOIL process. Those two will cancel out. So I got a positive and a negative, so I know it's going to be negative. 2 i's is I squared. And then square root of 5 times square root of 5 is just simply 5. Okay, not too bad. So we got 18 minus 3i square root of 5. And down below, I got 36 minus I squared. There it is again. Okay, we know that's negative 1 now, times 5. Is everybody with me? Lastly, we're almost there. 18 minus 3i square root of 5. 36, two-stroke method here. Okay, those become positive. 36 plus 5. So I get 18 minus 3i square root of 5 all over 36 and 5 gets me 41. And that is more than good enough for your answer. The last comment I would like to add about this problem is the fact, notice that we got that I hidden between the 3 and the square root of 5. If you go to check your book and check for the answer, the textbook is going to give this to you. What they are doing is they are breaking up their A's and the B's. So it's clear that the 18 over 41 is your A, and the 3 square roots of 5 over 41 is your B. And then they'll put the I at the very end. So there's your form A plus or minus BI. Okay, so we talked about a number of different things from lesson 69. Okay, don't panic, don't worry. This is the first time you've been exposed to complex numbers. What I want you to do is work on the lesson practice A through F, H, I, and N. All of these were the same examples that I just went over, so don't be afraid to go back to my notes, go back to the video, rewind it if you need to. Go to your book, there you are, the exact same examples in your book, okay, just with a little better explanation. And work on these on your own. If you need more help, we will go over those whenever I get back, okay? Do your best with these, that's all I ask, and then we will cover them more in depth when we see you again. Take care.